You talked about the concept of even teeth being able to heal. That's a new concept. So maybe share with our listeners kind of your philosophy and what you've seen professionally proven that that's how it works.
It all goes down to what a tooth is made of. So a tooth, the outside of the tooth, the part you see out here is made of enamel. You've heard that word before. What you may not have heard is that enamel is made of minerals, and the main mineral is called hydroxyapatite. Right. So it's basically a calcium phosphate complex that with a few other components. And that's what makes the outside surface of the tooth. Well, those minerals are held in a crystalline structure, so kind of a lattice like this. Right. And when we eat acidic food, or when the bacteria that are in our mouth eat acidic food or sugary food, they create acid. That acid actually pulls minerals out of that lattice. So I like to think of it a little bit like a threadbare blanket. Right. A blanket that has all the threads, inner versus a threadbare blanket. There's a lot of holes in there, or a sponge. Well, when you eat acidic foods, or there's a lot of bacteria that eat sugar and they create acid, it pulls the minerals out of the tooth. So what have we been told forever to do if that happens? Use fluoride, right? Might as well just dive headfirst into
there, right? That is such a hot topic, and I have lost friendships over this conversation.
Really, it honestly just comes down to what is fluoride. Fluoride is a similar component. Fluoride is similar to calcium. So what fluoride does is it will actually incorporate in that lattice of minerals. It will actually join that lattice and form a hard crystal in the tooth. It creates fluorapatite instead of hydroxyapatite. It's just a different form of a similar molecule. Okay. It is harder and more brittle than a hydroxyapatite molecule. So the harder part we like, right? Harder part's great because it's going to make the tooth more resistant to that acid attack, to acid dissolving it. One of the problems is the more brittle piece, right? Because hydroxyapatite is also the mineral component of bones. So when you're adding fluoride to the entire system, you're actually going to change the composition of your bone structure as well as your tooth structure. And a harder, more brittle bone is more prone to fracture. So what they're finding is higher rates of hip fractures and other fractures in areas that are highly fluoridated, because that fluoride has changed the crystalline structure of the bone itself. Well, I'm not okay with that.
I'm grateful for you, Dr. Michelle, and I'm grateful that you are the voice, because it needs to be shouted from the mountaintops.
My whole intent is to show that there's actually a better way. I don't even have to bash fluoride. I mean, I'm happy to do that if you want me to, but I don't even have to go there. I can just show you that there's actually very little fluoride naturally in a tooth structure. The mineral that's in the outside of a tooth, like we talked about, is called hydroxyapatite. So if the acid is dissolving minerals, they're dissolving hydroxyapatite. So why would we actually put something back to plug the hole, to make that threadbare blanket, thick again? Why would we actually put something back that was never there to begin with? Right. Why don't we just put the thing back that was lost?